Okay, in the last class, we were studying about the different sorting algorithms. Can you view the slides? Hello. Okay, complexity of sorting algorithms. Complexity of an algorithm measures the running time as a function of n. N is the number of items present in the number of numbers. Each sorting algorithm is made up of following operations where A1, A2, A3, etc. AN contain the item to be sorted. So it contains the following operation. First operation is comparison. In each and every sorting methods, sorting algorithms, we use some comparisons which test whether this A of I less than A of J. The next operation is interchanges, which switches interchanges or exchange, which switches the content of AI and AJ. We need to exchange the value between AI and AJ like this. This operation, AI and AJ content will be exchanged. So exchange operation. And next one is assignment operation. So normally there will be three operations: comparison, exchange, and assignments. Normally, complexity function measures only number of comparisons, since the number of other operation is at most at a factor of number of comparison. Okay, usually this complexity is measured in terms of the number of comparisons. First one is bubble sort. In ith pass, we need n minus I comparison. So totally there will be n minus 1 passes. So how will you calculate the complexity? Can you tell the complexity? So we are having n minus 1 passes, and in each pass we are having n minus I comparison. So how many steps will be there? How many total comparisons will be there? Tell me. Totally we are having n minus 1 passes. And ith pass means it need n minus I comparison. So what is the total number of comparison? Tell me.
N minus 1 into n minus I.
N minus 1 into n minus I. So the total time complexity is n minus 1 plus, that is, if it is the first pass, then I is replaced by 1. So n minus 1. In the second pass, this I is replaced by 2. Third pass I is replaced by 3. Like that, last pass we need one comparison. So what is this one? What is this? N minus 1 plus n minus 2 plus n minus 3 plus etc.
Sum
Tell
of
me.
n natural numbers.
Sum of n natural numbers. What is the equation for the sum of n natural numbers?
N into n minus 1 by 2.
N into n minus 1 divided by 2. So this is the sum of n natural numbers. So this can be replaced by n into n minus 1 divided by 2. So this can be written as order of n square, because we can replace, we can ignore the other terms. Actually, n into n minus 1 divided by 2 means you will get n square minus n divided by 2. So we can neglect this constant term, also this n, because we are preferring the higher order term. So the order is n square. So for bubble sort, the order is n square. Okay. What about the selection sort? Can you tell me the complexity of selection sort? Any idea? Anyone? Anyone? Actually, here we are finding the minimum in unsorted segment of length n requires one scan. First of all, we are going to find out the first minimum, smallest number. Smallest number from a length of n. It requires just one scan. So we are having n steps. In each iteration, segment to be scanned reduces by 1. So first we will find out the smallest number and it requires just a single scan. That means suppose we are having uh, suppose this is our numbers. These are the set of numbers. Which is the smallest one from these numbers? Which one is smallest?
One.
1. So how many scans are required to find out 1 is the smallest one? How many scans are required? Just one scan. We have to compare each and every elements in this set. How many comparison are needed? Actually, what is the procedure? What is the procedure for doing this selection sort? First, we will set this 8 as a minimum value. Then from the next element onwards, we will this 8 is set as minimum. Then we will compare this 8 with the next numbers 48, 13, 2, 1. So we need just one scan. For finding the smallest number, we just need one scan. And in each iteration, the scan will be reduced by 1. So how many steps are there? In the first step, we need n. How many comparisons are required? We need to compare this 8 and 48. 1. Then we need to compare this 8 and 13. 2. 8 and 2. Third comparison. 8 and 4. So fourth comparison. So how many numbers are there? 5 numbers. 5 numbers means, so 5 is the length actually. So we need one comparison and one scan. And how many comparisons? 4 comparisons are needed in this step. In the next case, we will set this 1 as the smallest. And the number of this length will be reduced. This length will be reduced because we need to, after this step, do you remember selection sort? Oh, I just remove that numbers. I will write some other numbers. 8, 27, 13, 4, 1. So after finding that 1 is the smallest, we will exchange it. 1, 27, 13, 4, 8. So now the set is reduced by 1. So set is reduced by 1 means number of comparison will also be reduced. That's why in the first stage we are having n numbers. In the second stage we are having n minus 1. In the third stage, because here the smallest number is removed. So there will be n minus 1 comparisons. In the next case, we remove 2 numbers. In the next case, we will remove 3 numbers. So there will be n minus 3. Finally, we will get a single number. So again, what is this one? This one, n plus 1, n plus n minus 1 plus n minus 2 plus etc. 1. This can be written as, tell me, tell me. Hello, hello. പറയടോ, hello,
n
hello.
into n plus 1 by 2 plus 1.
How did you got it?
n natural മറ്റേത് n minus 1 natural number. ഇത് n
N minus, how will you find the sum of natural numbers? That is 1 plus 2 plus etc. plus
அப்படி
n
எழுதணும்.
minus 1, n minus 2
n
into,
വരെ
n minus 2 plus n minus 1 plus n. So what is the formula? Formula is n into n plus 1 divided by 2. Why this is n into n minus 1 divided by 2? Because there is no n here, right? Hello. So this is n into n minus 1 divided by 2. This is actually the sum of n natural numbers. That's why it is n into n plus 1 divided by 2. Because in the first step we are having n numbers, and in the next stage we removed the smallest number, and there will be, suppose if there are 5 numbers, if there are 5 numbers in this series, we will remove the smallest one and then we will compare the remaining 4 numbers. That means the size is reduced by n minus 1. And in the next stage again, we will remove the smallest one from this series, that is 4. Again, the size will be reduced by 1, like that. So we will finally we will get a single number. So uh, running time is n into n plus 1 divided by 2. Okay, again this is n into n plus 1 means n square plus n divided by 2. Again, higher order term is n square. So order is n square. Order is n square. Next is selection, insertion sort. In insertion sort means we will inserting a new value in the sorted segment of length L, requires up to k steps in worst case. In each iteration, sorted element in which to insert increased by 1. So T will be T of n equal to, so in the first stage, we will select the new value and it will be kept at the right position. So remember the example of cards. We will select one card and put that card in the sorted order. So it requires just one step. Means in the next stage we are having two elements, two steps are there. Means the last class we had studied about insertion sort. Okay, this is insertion. So how many comparisons are required for this stage? We just compare this 2 with this 8. Only one comparison is needed. What about the second number? First we will compare this 8 with 4. Sorry, 4 with this 8. Again we will compare this 4 with this 2. So we need two comparison. First we will compare this one 4 and 8, first comparison. Next we will compare 4 and 2, so second comparison. So in the first stage we are having one comparison, here we are having two comparison. What about the third stage? Third stage means 9. We will compare 9 with 8. 9 with 8, this is 1. Again 9 with 4, this is 2. 9 with 2, that is 3. So there are three comparison. What about the next case? How many comparisons are needed?
4.
Hello. Hello.
4.
4. Like that, we will get 1 plus 2 plus 3 plus etc. N. Finally, we will get n minus 1 comparisons അല്ലേ? Okay, therefore T of n equal to 1 plus 2 plus etc. plus n minus 1. So again this is the sum of n minus 1 natural numbers. Sum of n minus 1 natural numbers means you will get n into n minus 1 divided by 2. Again the higher order term is n square. So complexity of this insertion sort is also order of n square. So this is a comparison. Actually, you have to study this table. Bubble sort in worst case, best case, and average case all are n square. Selection sort means selection sort also it is n square. Best case, average case, worst case. All in all cases we are having complexity n square. What about insertion? Best case means it is order of n. It is not order of n square. In best case, it is order of n. In other two cases, it is order of n square. Okay, remember those points. Next, we will continue with the next sorting. We will move to the merge sort. Can you view the slides?
കാണാം.
Okay, actually merge sort means it uses a technique known as divide and conquer technique. So first of all, we will divide the problem into two or more smaller instances of the same problem. So we are having a large problem. We will divide that large problem into smaller instances. Then we will solve the smaller instances recursively. And after solving the smaller instances, we will combine all the solution of this smaller instances to form the original instance. The recursion stops when an instance is reached which is too small to divide. I will explain. So this is the set of numbers. We will divide this into two sets. Then we got two sets with four numbers. Actually, we are having 8 numbers in the larger set. We have divided it into two. And in each set, we are having 4 numbers. So this step is known as divide step. This step is known as divide. After that, we will solve this smaller set separately. We will solve this smaller set. Actually, this smaller set, each smaller set is having 4 elements. Again, we can divide this smaller set with 2 elements. So again, this smaller set is divided into 2. Again, this smaller set can also be divided into 2. So again, this set is divided into 2. This set is also divided into 2. So we will get a set like this with single element. So first step is divide. So our technique is known as divide and conquer. So first we will divide it. So we will get a small recursively division is performed on this set of numbers. After that we will get a smallest set. Then the next stage is we have to perform some operation. Perform some operation means we have to find out the solution. Find out the solution. So we will find out the solution for smallest sets. After that we will get a large number of solution and then we have to combine. So divide, do some operation, solve it and combine it, merge it. So we are having three stages: division, solution, solve, and finally we will combine it. So here we are having divide the problem into smaller instances and solve the smaller instances recursively. Means we are having more smaller instances. So we have to solve all the smaller instances independently. After that, we have to merge, combine all the solution to form the original solution. The recursion stop when an instance that cannot be divided. Atomic stage. At the atomic stage, we will stop the recursion. So we are having two stages. Divide and conquer algorithm consists of two parts. Divide. Divide the problem into a number of subproblems. The subproblems are solved recursively. Conquer. The solution to the original problem is then formed from the solutions to the subproblems. So first of all, divide means we will divide the problem into subproblem, and next step is solution, finding the solution of subproblems. Then after that we have to conquer means we are combining the solutions. We have small solutions. We have to combine all the small solutions into a single solution. So merge sort. It is a sorting problem. Sort sequence of n numbers into non-decreasing order. So it must be in ascending order. Divide means divide the n element sequence to be sorted into two subsequences of length n by 2 elements each. So if we are having n elements, we have to divide that n elements into two sets with elements n by 2. Conquer means we have to sort these two subsequences. We are having two set of subsequences. We have to sort these subsequences using merge sort. Then we are, after sorting these one, we will merge it. Did you got this step? First we will divide, then we will sort the two subsequence, then merge it. Sorting is the solution of that subproblem. First, so this is our example. We are having 8 elements. So we will divide it into 2. We will divide it into 2. So each sub list has 4 elements. Again, these 4 elements, we are having 4 elements each. Again, we will divide each set into 2. So again, we are having 2 element set. Again, we will divide the 2 element sets into 2. So what is our steps? First, we will divide. After division, we have to solve the subsolution. Solve the subsolution means our solution here is sorting. So we are having two sets. We have to merge these two sets after sorting. So which is smallest one? Tell me which one is smallest?
23.
23. So we have to put 23 first. So among these two numbers, we are concentrating on these two sets. So again, these two set is divided into two. We will get single set with 98 and 23. So from this one, actually this is the same step. Don't get confused. Actually, 23 is smaller than 98. So we have to move this 23 first. 23 and 98. So after that, we will merge it. Then again, we will concentrate on these two elements. from processing starts from left to right. So first of all, we have to complete all the left set, then move to the right. So this set is over, then we will move to this set. So again, we are having two elements, which is smallest.
14.
Okay, again, this is divided into single sets. So comparing these two elements, 14 is simple. So we will get 14. Solution is this one, 14 and 45. Then we have to merge it. Merging means how many elements will be in that set after merging? How many elements will be present after merging? Tell me how many elements. Actually, we are concentrating on this only. So there will be how many elements?
2.
Two elements. So we will get 14 and 45. Okay. So don't go add these elements into this set. So we are having two single sets 45 and 14. 14 is smallest. So we'll 14 is moved first. Then after that 45. So with two element set. Again, now these two cases are over. Again, we have to check these two sets. So we have to compare the first element in this set and the first element in this set. Which is smallest?
14.
14. So we will move 14 to this four element set. After that, we have to compare. 14 is over. 14 is over. So the pointer will move to this one. Here the pointer is moved to this one. So we will compare 23 and 45. Which is higher? Which is smaller? Which is smaller? 23 or 45?
23.
So, so after 14, we will move 23 to the set. So again, we had used this 23 and 14. So the pointer is moved to 98. Here the pointer is at 45 only. So we have to compare 45 and 98. Which is smaller?
45.
45. So we have to move 45 to the four, four element set. So 45 is here. After that, you can place 98. So we will get, so this set is complete. This set is over. This set is over. We had sought this subset. Now we will move to the right side subset. So again, this set is divided into two. Four element set is, this four element set is divided into two. Again, this two element set is divided into two. Again, we will sort it and combine it. So actually 6 and 67 are in order. So we can place 6 first, after that 67. Then we are having one more two element set. So it is also in sorted order. So we will divide it first. It is also in sorted order. So we can directly merge it. So again, we will get a two element set. It is 33 first, followed by 42. Then we have to combine these two element sets. We have to merge this set and this set. So we will, pointer will be at this position and this position. So we will compare 6 and 33. Which is smallest? Which is smallest?
6.
6. So we will remove 6 from this and add to the third list. Then the pointer will be moved to 67. Here there is no change in pointer. So we will compare 33 and 67. Which is smallest? Which
33.
is smallest? 33 is smallest. So after this, we will move 33. So 33 is used. So again, the pointer will be moved to 42. Here the pointer is at 67. We will compare 42 and 67. So which is smaller?
42.
42. So we will place 42 here. After that, we will place 67. So this four element sorting is over. Okay. Now what is the next step? Actually, here we are having 8 elements. We had divided into 4 element set. Now we got two 4 element set. So we have to combine these two 4 element set. So how will you combine it? So we have to merge these two sets. So now pointer is pointing to 14 and here it is at 6. Which is smaller?
6.
6. So we will move 6 first. So we had used this 6. So pointer is moved to the next location. Here the pointer is at 14 only. Again we will compare 14 and 33. Which is smallest?
14.
So move 14 to this location. 14 is used means pointer will be at this point and 33 pointer will be at 33. So we will compare 33 and 23. Which is smallest?
23.
What is the next step?
23 le pointer 45.
Ah, yes. Pointer will be moved to 45. Okay, what is the next step? Tell me. 23 is moved. Now pointer is at which location?
45 le 33.
45, 33. What is the next step?
Compare 33 small.
Compare. Okay,
Moving.
compare 33 and 45. Which is smaller? 33 is smaller. What we have to do?
33 move ചെയ്തിട്ട് പോയിന്റ് 43
Ah,
ലോട്ട് പോകും.
yes, 33 is moved. So we had used 33. So pointer will be moved to 42. And here pointer is at 45. Okay, tell me what's the next step?
Compare 45 and 42.
Yes, compare
Smallest 42.
45 and 42. Smallest is 42.
Move
So
42.
42. Move
Move.
42. Move 42. So moving after moving 42, what is the next?
Pointer
Here
60.
pointer is at 45. 67. Compare 45 and 67. Which is smallest?
45.
45 is moved. Okay.
Hmm.
Now 45 is used. So
Pointer is moved to 90.
pointer is moving to 98. So we have to compare 98 and 67. Okay, what is the next step?
Compare it smallest 67 moving.
Smallest is 67. So move it. Then only one element remains. So you can move 98 to the set. So this is our final sorted list. From this set, this is unsorted list. From this set, we got the sorted list. This type of sorting is known as merge sort. So from this sorting list, this is unsorted list, and this one is the sorted list. Okay, did you got the logic? Hello.